Have you ever stared at a photo of the Great Pyramids or Machu Picchu and just thought, how on earth did they build these colossal, perfectly aligned structures thousands of years ago? They didn't have cranes, they didn't have laser levels, they didn't have power drills. All they had were basic tools, human muscle, and an incredible amount of ingenuity. It's a question that has baffled historians, engineers, and conspiracy theorists for centuries. Today, we're going to peel back the layers of mystery and explore the incredible techniques ancient civilizations used to create wonders that still stand strong today. Forget what you think you know, because the reality is far more impressive than any alien theory. Let's start with the absolute basics: moving massive stones. We're talking about blocks weighing several tons, sometimes even hundreds of tons. The popular image is thousands of workers pulling ropes, and while that's part of the story, it's much more sophisticated. Take the ancient Egyptians. For the pyramids, they quarried limestone and granite, sometimes from hundreds of miles away. How did they move them? Or recent discoveries suggest they were masters of friction reduction. An ancient tomb painting actually depicts a large group of workers pulling a massive statue on a sledge. But look closer, right in front of the sledge, a person is pouring water onto the sand. This simple act of wetting the sand could cut the pulling force required by half. It's a brilliant, low-tech solution to a monumental problem. They also used rollers. By placing logs under a massive stone block, a team of workers could roll it across flat ground with significantly less effort than dragging it. It's the same principle we use today with ball bearings. But what about getting those stones up a steep, rising pyramid? The most widely accepted theory is the use of ramps. But not just one straight ramp like you might imagine. That would need to be incredibly long and steep. Instead, archaeologists believe they used a system of switchback or spiral ramps wrapping around the pyramid as it grew taller. This allowed for a more manageable gradient. These ramps were likely made of earth, rubble, and brick, and then disassembled once the pyramid was complete. Now, let's talk about cutting and shaping these stones with mind-boggling precision. The gaps between the stones of the Great Pyramid are so fine you can even slip a piece of paper between them. How did they achieve this without diamond-tipped saws? The answer lies in patience and simple, effective tools. They used copper saws, which are relatively soft. But here's the trick: they used them in combination with an abrasive, like quartz sand. By constantly feeding sand into the cut, the soft copper saw could slowly, but surely grind its way through hard granite. Think of it like a wet saw for tile today, but powered by human arms and grit. For drilling holes, they used bow drills, rotating a copper tube with that same sand abrasive to core out sections of stone. It was a slow, laborious process, but it worked. And what about lifting? Once you've moved a 50-ton granite block to the construction site and shaped it perfectly, how do you lift it into place hundreds of feet in the air? This is where levers and counterweights come into play. The ancient Egyptians were masters of simple machines. By using long, sturdy wooden levers, a small group of people could lift and pivot enormous weights. Imagine a giant seesaw. By placing the heavy stone on one end and having a team of workers pull down on the other, they could raise the block. They also likely used rocker-like wooden cradles to maneuver the blocks into their final resting place with millimeter accuracy. It wasn't about brute force alone, it was about understanding physics and leverage. Let's journey from the sands of Egypt to the mountains of Peru. The Inca civilization built incredible structures like Sacsayhuaman and Machu Picchu. What's astonishing here is their stonework. They didn't use mortar. Instead, they cut massive, irregular stones to fit together like a perfect puzzle. This technique, called ashlar masonry, makes their walls incredibly resistant to earthquakes, which are common in the region. During a tremor, the stones can actually move slightly and then resettle into their original position without the wall collapsing. So, how did they create these perfect fits? The technique was likely a process of scribing and pounding. They would place a new stone on top of the one below it, trace the contours of the bottom stone onto the one above, and then painstakingly chip and grind away the excess rock. They would repeat this process over and over, lowering the stone, checking the fit, lifting it, and chipping away a little more until it fit perfectly. They used harder hammerstones to pound the rock into shape. It's a testament to their incredible patience and craftsmanship. And it wasn't just the Egyptians and the Incas. All over the world, we see this pattern of human ingenuity. At Stonehenge in England, the massive bluestones were transported over 150 miles. In the ancient Roman Empire, they perfected the use of concrete, creating structures like the Pantheon with its enormous unsupported dome that still stands as the largest of its kind in the world. They developed cranes, powered by human treadmills, that could lift significant loads. At the Moai statues on Easter Island, giant stone heads were carved from volcanic tuff, and then walked to their platforms using a system of ropes and rocking motions, a process that has been successfully recreated by modern archaeologists. The common thread is not some lost advanced technology or alien intervention. It's a deep understanding of mechanics, materials, and the environment, combined with immense social organization and a multi-generational commitment to a single project. Think about the sheer scale of the workforce and the planning involved. Building a pyramid wasn't a weekend project. It took decades, sometimes the entire reign of a pharaoh. This required a level of project management that would rival modern construction firms. You had to feed, house, and organize tens of thousands of workers. You needed scribes to keep records, overseers to manage the teams, and artisans with specialized skills. These weren't just laborers, they were skilled craftsmen who took immense pride in their work. We have evidence from workers' villages near the pyramids that shows they had access to good food, medical care, and lived in organized communities. They were building a monument for their god king, a project that had immense cultural and religious significance. This shared purpose was a powerful motivator. So, when you look at these ancient marvels, don't see an unsolvable mystery. See a celebration of human potential, see the power of collaboration, the brilliance of simple machines, and the incredible results of patience and hard work. They didn't have the tools we have today, but they had something just as powerful, an unyielding will to build something that would last forever. And in that, they succeeded beyond their wildest dreams. The next time someone tells you it must have been aliens, you can tell them the real story is far more inspiring. It was us, we did that. Thanks for joining me on this journey back in time. It's amazing what we can learn by looking at the past. If you enjoyed this exploration of ancient engineering, make sure to hit that like button and subscribe for more deep dives into the mysteries of our world. Let me know in the comments which ancient structure fascinates you the most. See you in the next video.